see the distant stars like this, I can't see that rotating relative to the distant stars, I just feel this weird kind of artificial gravitational, maybe not real, I feel this artificial gravitational field. I'm hanging onto an apple like this in my hand, and I notice that in this state of whatever is happening, in this state, I feel like I'm pushing up on this apple. Okay, so I'm exerting an upward force on this apple. Okay, so that's exactly the same as Bob standing on the surface of the Earth. Okay, I'm standing on the surface of the Earth here and hold this piece of chalk. I have to keep pushing up on this piece of chalk, so I'm exerting this upward force. Okay, so far so good. So with this simple experiment, Bob wouldn't be able to distinguish between whether he's inside this rotating space station or whether he's on the surface of the Earth holding this apple. In both cases, it's phenomenologically the same. He's exerting an upward force. Okay, what if Bob releases the apple? What if Bob just drops it like this? What if he removes his hand? So this apple is whipping around. So Bob and the apple are whipping around and around and around and around like this. And then suddenly, at this instant of time over here, Bob releases the apple. What's going to happen to the trajectory of the apple? Okay, it's going to move exactly tangential to the circle. So whatever the velocity the apple had, at the instant that Bob released it, it would maintain that velocity. There's now no more force acting, the acceleration stops, the velocity remains constant. It remains exactly what it was at the instant it was released. Okay, so what will happen is the trajectory of the apple will change from a circle to just a straight line. Okay, it's just floating freely in space. This is empty space. You release an apple from that point with that velocity, it just travels in a straight line like that. Okay? But now while this apple is traveling on this straight line, during that time, Bob is also still moving around. Right? So by the time the apple hits the inside wall at this point, Bob will have turned around, Bob himself will have turned around so that now he's standing over here. Okay, and you'll notice that the apple hits the ground, what Bob considers to be the ground, hits the ground right at Bob's feet. Okay, so let's see if that's the same. So here on the Earth, we've got Bob, he releases the apple like this, and what happens is it just goes clunk and it hits the floor. Moreover, it accelerates toward the floor. So as it's falling, it's picking up speed faster and faster and faster. Okay, and that's actually what's happening here. So if you notice, let's use a different color chalk so we don't get too messy here. You'll notice that initially, the initial velocity, just the instant that Bob releases the apple, the initial velocity of the apple is like this. The initial velocity of Bob is exactly the same. Okay, so the apple and Bob have exactly the same velocity vectors. What is their relative velocity? 0. The difference of the two velocities is 0. Okay, so as far as Bob is concerned, when he releases it, for a split second, it just has 0 velocity. It's just hovering there for a split second. Okay, but then as time goes on, you'll notice that the distance between Bob's feet here and the apple gets less and less and less. Okay? The apple is not accelerating. The apple is moving on a straight line, but the floor is moving on this curved trajectory. The floor is accelerating. In fact, the floor is accelerating up toward the apple. So at this instant of time, the apple and the floor are on parallel forces. Okay, and there's very little relative velocity. But by the time the apple gets over here, the floor has bent around like this and accelerated upward, and it's going slam. It's accelerating up and hitting the apple. Okay? So you can see just from this picture that the relative velocity between the apple and the floor is going to be increasing as the apple approaches the floor, which is exactly what we see here. Okay? Starts off falling slowly, picks up speed faster and faster and faster, and then it hits the floor. Okay? So far so good. So with these two simple experiments, Bob can't distinguish between whether he's in this rotating cylinder floating out in space, or whether he's just standing on the surface of the Earth. Okay? And for all of these things, what we're going to imagine, actually, I'm sort of exaggerating the situation here, what we're going to be imagining is that the space station is rather large compared to Bob. So Bob is actually down here. Okay, so the space station is rotating like this, and Bob and his apples and all that stuff are just really small, on a small scale compared to the entire space station. Okay? So these two simple experiments indicate that this artificial gravitational field very well mimics the experiences when we're having a real gravitational field on the surface of the Earth. Okay, so are there any other tests that we can do to see how well this artificial gravitational field mimics a real gravitational field? You throw it up. Okay, so you can toss it like this, see what happens. Okay, so we pull like that, and he would pull like that, and is that a parabolic trajectory? No. Okay, what other tests? What about a weigh scale? What if you had a weigh scale? A weigh scale is like a spring scale like this. You stand on that scale and you determine your weight. Would a weigh scale work the same in this rotating space station artificial gravitational field as on the Earth? What about a balance scale? So a balance scale is like this. And you stick a mass there, you stick a mass there, and you adjust there, whatever, until it's balanced. Would that work the same? Okay, so I encourage you to sit back later on and think about this, and then come up with different tests that you can do to try to distinguish between this and this. Okay? Anyway, so as far as it goes, as far as we've said so far, it certainly looks like the artificial gravitational field mimics a real gravitational field quite well. So why is this significant? Well, here comes Einstein. Okay, so first of all, Einstein realized, this is after special relativity, after Einstein has realized there's a universal speed limit, and he understood time dilation, like traction and all that stuff, relativity of simultaneity, he starts turning his attention to gravity. Okay, and he recognizes that Newton's model of gravity, Newton's picture of gravity, the mental construct that Newton made to try to make sense of this phenomenon called gravity, must be wrong. there are two main reasons, two simple sort of ways to think about this. One reason is theoretical. The other is experimental. So the theoretical reason has to do with what I just said, that there's this universal speed limit. Okay, so all physical phenomena respect the fact that information of any kind cannot be transmitted from point A to point B faster than the speed of light. Okay, so now Newton's model of gravity does not respect this. Newton's model of gravity doesn't have anything to do with time in it. Newton's model of gravity is an action at a distance, an instantaneous action at a distance. So what do I mean by that? What I mean is, suppose that you've got the sun here, and we've got the Earth going around the sun. Okay, and according to Newtonian gravity, the Earth exerts a force on the sun, and vice versa. And the force that the Earth exerts on the sun is precisely that center directed or centripetal force required for the Earth to be in circular motion. Okay, that's Newton's model of gravity. Okay, now the problem with that is the force, according to Newton, the force the sun exerts on the Earth depends upon the instantaneous positions of these two bodies, okay, at the same instant. Okay, now remember relativity is simultaneity. When you say that these two events are happening simultaneously, well, simultaneous are true. Okay, so right away this is going to be a bit of a problem, you can see. But a simpler way to see that is, let's suppose that at one instant of time, the sun suddenly disappears. So we're a magician and we can make the sun magically disappear. Okay, so at some specific, so here's the Earth wheeling around in orbit here, and at this particular instant of time, when it's at this position, we suddenly remove the sun. What's going to happen, according to Newton's model of gravity, to the trajectory of the Earth? Sorry, the instant that we remove the sun, according to Newton's model of gravity, the gravitational force is instantly gone, because the gravitational force is g times m to 2 masses divided by r squared. There's no issue of time here, okay? This r here is the instantaneous distance, etc. Okay, so when we pull this guy out, this force disappears. No more center-directed force, just like the apple in the space station, bang, it takes off on this trajectory. And we would know instantly that has happened.
As I began to contemplate composing this paper, I had a long conversation with a distinguished New York antiquarian bookseller. Why, I asked him, do people collect autographed literary manuscripts? Without hesitating, he responded, to make a lot of money. But this, of course, begs the real question. Why do collectors offer large sums to possess autographs of manuscripts and original typescripts of famous writers, composers, historians, and scientists? If, for example, someone in England should find in a hidden drawer of an antique desk an autographed manuscript of Shakespeare's Hamlet, why would it be of inestimable value? The response, I believe, would be trifold. First, an autograph of a literary manuscript is a secular relic, like a bona fide fragment from St. Thomas's skull or the Shroud of Turin. Such an object, were it to be veritable, would tangibly link us to a personage of the past. The desire to feel physically close to our literary forebears is human and natural, shared by the most humble and the most erudite. A second and more substantive reason is that an autograph guarantees the authenticity of a composition and implicitly of a special textual tradition. Thus, codices previously attributed to the hand of Augustine, Jerome, and Ambrose were both regarded as relics of these saints and guarantors of the authorship of celebrated and venerated patristic works. Important as the aforementioned roles of the autographed manuscript are, and have been from medieval times onward, another and most important role of the autograph is to give insight into the authorial process. Since at least the 19th century, students of literary history have searched for and carefully preserved manuscripts that record by erasure, marginal, and interlineal annotations, notes de renvoi, arrows, and light marks, the creative process by which a first draft evolves into a memorable and fully confected masterpiece. It is important when we turn to antiquity, the Middle Ages, and the early Renaissance to realize that autographs of this character that provide such insight into the creative process are either entirely absent or scarcely present. The autograph attributed falsely to Virgil is a telegraphic manuscript. Equally telegraphic are the codices previously attributed to the late antique church fathers like Augustine. The illuminations and paintings of the Middle Ages and Renaissance that show Cicero, Augustine, and Ambrose writing their compositions are in fact anachronistic. The Greeks and Romans, and here I differ somewhat with the previous speaker, generally composed in dictation to secretaries, who took down their words in syllabic shorthand, either on wax tablets or in parchment notebooks. The antecedents of the medieval codex that before the 3rd century were used primarily for provisional notes and not for a compacted text, for which the appropriate medium would have been the laterally extending scroll. Rare indeed were figures like Ambrose, who are known and wrote about and who acknowledged through writing their own letters and tracts. As I have explained elsewhere, the ancient culture of belles lettres was largely an oral one, in which the process of composition, like that of reading, was habitually vocal. The attraction of the classical world of letters with its division of labor between authors, secretaries, and professional readers within the confines of monastic communities, such as Cassiodorus' retreat at Bavarium, undoubtedly brought authors into more intimate contact with the books that contained their texts, which by this date were almost exclusively in codex form. Cassiodorus was concerned with text formats that would simplify reading, such as the lines of sense, per colla et comata, espoused by Jerome to aid simple confreres, punctuation, perhaps even the insistent aeration characteristic of certain late antique Christian codices written in scriptura or continuous writing. But we must remember all that right at the time of the ancients and in the Roman Empire and for the whole period of Greek antiquity, there were no spaces between words and virtually no punctuation. Elsewhere, I set forth the general thesis that the full word separation that came to characterize all insular Latin script in the late 8th century permitted the evolution of silent reading. Logically, this new script that enabled the silent and entirely visual decoding of text would have fostered silent autograph composition. However, the use of wax tablets and of parchment booklets similar to those employed in late antiquity has left us bereft of any tangible evidence of authorial autograph activity in the British Isles, where at any rate most surviving Latin books were copies of the Gospels. Johannes Scotus, an Irishman at the court of Charles the Bald in the 9th century, however, left word-separated corrections as additions to the formal scribal transcriptions of his works, which had been copied from prior drafts by continental hands in unseparated script. Word separation, which enhanced the manipulation of written text, was a prerequisite for the modern draft autograph. Authorial codex, that is, text written in formal book script with occasional corrections reasonably attributable to the author, became characteristic of word-separated literary circles from the time of Johannes Scotus to the end of the 10th and into the early 11th century. There are a number of examples, of which the most famous is Reicher's Chronicle of the Franks, which is only one codex in Bamberg, which has some revisions in it. Others include the Jests of the Bishops of Cambrai, which is associated in the 11th century with Gerard of Cambrai, which has authorial, thought to be authorial marks in it and revisions. Another with far fewer marks is the reputed authorial codex containing the poem of which Alberon of Laon composed for King Robert the Pious. At St. Gall, the earliest major continental center of word separation, Noker Baubolus, the author of liturgical texts in the early 10th century, explicitly refers to the notebooks that he used for composing preliminary versions of his works. Notebooks, along with wax tablets, surely continued to serve an important draft function for the authorial creative process. 10th and 11th century examples of such artifacts, however, scarcely survive. Indeed, we only have a single example of a codex which might be deemed a notebook, and only a very few wax tablets, none of which bear witness to autograph composition. However, in literary texts, the increasing practice of composing in written form has left its traces. Guibert de Nogent, at the end of his life, lamented that due to incipient blindness he could no longer write his text, but was obliged to dictate to a secretary. The case of Guibert is particularly revealing, for although quite clearly somewhat of an eccentric, he felt free in written form to write erotic poems and record disturbing dreams and fantasies, which, it is fair to speculate, he might have been more hesitant to divulge orally to his secretary. Even earlier, Antoine de Saint-Amand, active in an early South German center of word separation, expressed his own erotic fantasies within the new medium. Abelard's History of his Calamities is a 12th century example of this genre. However, the artifacts that might have documented the documentation, the drafting of such composition of these works of a highly personal character have all vanished. If the medium of word-separated script enhanced the propensity of authors on occasion to write their own compositions and, more frequently, to correct and modify compositions transcribed by secretaries, the writing materials of the pre-scholastic period and later of the scholastic age were still not conducive to the use of the pen as a primary instrument for composition. Parchment was expensive, which has been made today, and relative both to ancient papyrus and modern paper, a difficult support on which to write. Wax tablets constituted a more user-friendly alternative for short sections of text, but because of their limited surface, they were clearly incapable of receiving a full draft of an entire opus. It is thus within the demi-oral milieu of scholastic composition characteristic of universities in the Central Middle Ages that the enigmatic vocabulary for the authorial composition of medieval composition must be assessed. Here the term dictare retained its ancient meaning of composing orally a text, although on occasion the verb might also be used to refer to text composed entirely in written form. The verb dictare is in the sense of reading aloud a fully composed text as a means of rapidly producing copies occurred really only after the year 1400. Dictare was indeed the normal word for literary composition and could refer to either written composition or oral composition. At the same time, the term scrivere was replete with comparable ambiguity. St. Bonaventure, in a famous passage of his preface to his commentary on the sentences of Peter Lombard, enunciated 4 meanings of scrivere that might be, for simplicity, be summarized as 3 separate activities. For Bonaventure, scrivere to write might refer to the activity of copying, that is, of book production, the activity of compiling, that is, of copying and extracting and combining text of works of recognized authors, and implicitly of reordering these works with subdivisions to enhance their clarity, and lastly, the activity of authoring, that is, the expression of the writer's own opinions in what we would term original written composition. Before the late 14th century, the oral dimension of composition was most important in those varieties of text that were most distinctly removed from the process of compilatio. The epistle and the sermon were 2 genres which were usually short works that to a large degree were spontaneously generated viva voce. In contrast, the written dimensions of authorship is most in evidence in the scholastic genres that included compilations of canon law, commentaries of the sentences of Peter Lombard, commentaries on scripture, commentaries on Aristotle, and in their derivatives, the summas of theological thought. Here the process of ordinatio and compilatio were most in evidence, and as Bonaventure's remarks suggest, in such works the tasks of author and of scribe impinged upon each other. In the 14th and 15th centuries, scholastic writers increasingly dissected, segmented, and recombined chunks of prose drawn from both the ancient fathers and 13th century masters. We moderns tend to think of that composing a late scholastic work such as Jean Rousseau's commentary on Aristotle's Ethics and the copying of a book of hours such as the Newberry Library Manuscript 56, The Hours of Marguerite Poix, were by definition totally different ventures. And yet, viewed in a larger perspective, the process as far as Bonaventure's remarks imply profoundly related. Rousseau, the author, acted as scribe when he derived blocks of sentences from the interior commentaries of Albert Magnus, Thomas Aquinas, and Johannes Burda. His original contribution was chiefly in the nuances of his responses to pre-established questions. That which was unique was a very small percentage of the entire prose content of his tome. Similarly, the scribe of each book of hours was an author in the sense that he chose and sequenced the devotional prayers that might compose a large portion of his volume. As scribe compiler, he had the liberty to add nuances by rephrasing the rubrics, indicating the modes and uses of prayer. These brief textual elements that constitute a minuscule percentage of the prose content of a book of hours, to the modern scholar may be among its most original and significant aspects. In the milieu of the Carthusian convent of the 15th century, the scholastic mode of written composition through a compilation reached its zenith in a world of solitary silence. In the massive opera of Denis the Carthusian that fills over 40 printed volumes, virtually the entire content is a syncretic ordinatio of prose elements drawn from the fathers, earlier scholastics, and liturgy. Three highly significant changes are responsible for the evolution of the autographed manuscript into a document conducive of preserving a record of authorial creativity, the very document that collectors so want to achieve and possess. The first of these was the introduction of paper, beginning in the late 14th century, paper for books as opposed to paper for documents. Paper preempted the use of wax tablets and provided a medium for authorial composition potentially suitable for preservation. 15th century paper codices, particularly those of the Carthusian order, will offer us far more tangible examples of the medieval compilatio that survived for the central Middle Ages and the first 5 years within the